This is a real photograph, not a rendering, not an artist's impression. A photograph taken on the surface of another world by a machine that should not have survived long enough to take it. The temperature was hot enough to melt lead. The pressure was equivalent to being nearly a kilometer beneath the ocean. The atmosphere was corroding the spacecraft from the moment it landed. It lasted 127 minutes. Then Venus destroyed it. In the last 30 years, humanity has sent 29 spacecraft to Mars. In that same period, we sent one to Venus. One. This is strange because Venus is closer. Venus is more Earth-like in size and mass than any other planet. And Venus, we now believe, may have once been the most habitable world in the solar system after our own. So why did we stop going? The answer starts in 1962. A NASA probe called Mariner 2 flew past Venus and became the first spacecraft in history to successfully study another planet. What it found ended a century of speculation. Astronomers had imagined Venus as a warm, humid world beneath its clouds, a possible twin of early Earth, perhaps covered in oceans, perhaps hosting jungles. Mariner 2 measured the surface temperature at over 460 degrees Celsius. Not warm, not humid, hot enough to melt lead. The dream of a habitable Venus died in a single afternoon. For the next 20 years, the Soviet Union did something the United States would not. They kept going. The Venera program was one of the most ambitious and least celebrated achievements in the history of spaceflight. Between 1961 and 1984, the Soviets sent 16 spacecraft to Venus. Most failed, some spectacularly, but a handful succeeded in ways that still have not been matched. In 1970, Venera 7 became the first spacecraft in history to survive a landing on another planet. Not Mars, not the Moon. Venus. It lasted 23 minutes before the atmosphere destroyed it. In 1975, Venera 9 sent back this image. It is the first photograph ever taken from the surface of another planet. Not Mars, not the Moon. Venus. Look at it carefully. Look at the rocks, the horizon that seems too close, the diffuse light filtering through an atmosphere so thick it bends the sky. And in 1982, Venera 13 sent back these, the first color photographs from another world. The spacecraft that took them lasted 127 minutes. It was designed to survive for 32. Then the Venera program ended. The Soviet Union collapsed, and Venus became a place no one visited. For decades, everything we knew about the surface of Venus came from these images. A handful of Soviet photographs taken by machines that were dying as they worked. In 1990, NASA sent one more mission, Magellan. It did not land, it could not. Instead, it orbited Venus for 4 years and used radar to see through the clouds. Magellan mapped 98% of the surface of Venus. And what it found was strange. The surface of Venus is young, not young in human terms, young in planetary terms. Less than 500 million years old. On a world that formed 4.5 billion years ago, this should not be possible. Something resurfaced Venus. Something violent enough to erase almost every trace of what came before. The leading hypothesis is that Venus, at some point in the last half-billion years, experienced a catastrophic global resurfacing event. Not eruptions like Earth's, something larger. Something that may have covered most of the planet in molten rock over a geologically brief period. And Magellan found something else. Enormous circular structures scattered across the surface, ranging from tens to hundreds of kilometers across. Scientists call them coronae. They don't have clear equivalents anywhere else in the solar system. They appear to be the surface expressions of hot plumes of material rising from Venus's interior. a geological process fundamentally different from anything happening on Earth. Venus is not just Earth with a thicker atmosphere. It's built differently. It behaves differently. And it may still be doing something no other planet does. Here is where the story turns. For 30 years, the Magellan radar data sat in archives, studied, cataloged, published on, but not in any comprehensive way, searched. The dataset was too large. The signal was too subtle. Finding what might be there would require someone to look, image by image, at thousands of square kilometers of Venusian terrain, hunting for something that might not exist. In 2023, a planetary scientist named Robert Herrick did exactly that. He compared radar images of the same volcanic vent, taken 8 months apart in 1991. And in the second image, the vent had changed. It had grown larger. Its shape had shifted. Fresh material appeared flowed out of it. Venus was volcanically active, not billions of years ago, not millions of years ago, in 1991, possibly still. This changed everything. In 2020, 3 years before the Herrick discovery, another team of scientists announced they had detected phosphine in the atmosphere of Venus. Phosphine is a gas that, on Earth, is produced almost exclusively by living organisms. Its presence in Venus's clouds was, and remains, extremely difficult to explain through known chemistry. The finding was controversial. It has been challenged, defended, reanalyzed, and debated for 6 years. It has not been resolved. But it did something important. It made Venus a serious question again. Within 3 years, 5 different space agencies announced missions to Venus. NASA, the European Space Agency, India, China, and a private company, Rocket Lab, planning the first commercial mission to another planet. In 3 years, Venus went from forgotten to crowded. The first of these missions is DAVINCI. It launches in 2029. DAVINCI will not land. It will fall. A titanium sphere approximately the size of a small car will drop through the entire vertical column of Venus's atmosphere, sampling the air continuously as it descends. It will measure the chemical composition of the clouds. It will hunt for the fingerprints of past oceans. And it will attempt to answer the question that phosphine raised. Is there anything in those clouds that shouldn't be there? Nothing like this has been attempted since 1985, when Soviet balloons floated through Venus's atmosphere for 46 hours before contact was lost. Nothing has flown through those clouds in the 40 years since. DAVINCI will change that. Behind DAVINCI comes VERITAS. VERITAS will not descend. It will orbit using radar significantly more advanced than anything Magellan carried, mapping the surface of Venus at resolutions that will reveal for the first time whether volcanoes are still erupting today. And behind VERITAS comes EnVision, the European Space Agency's mission, designed to study the interaction between Venus's surface, atmosphere, and interior as a single connected system. Where VERITAS asks what the surface looks like, EnVision asks how the whole planet works. 3 missions, 3 different questions, all arriving within a decade. For the first time in 40 years, we're going to see Venus clearly. Here is what the evidence currently suggests, though DAVINCI will help confirm or reject it. Venus, 4 billion years ago, may have looked like Earth. It may have had liquid water oceans. It may have had a stable climate. It may have been habitable for hundreds of millions of years, possibly for as long as 2 billion. Then something changed. The sun grew brighter. Water vapor accumulated in the upper atmosphere. Ultraviolet radiation split those water molecules apart, and the hydrogen escaped to space. The oceans evaporated. The greenhouse effect ran away. Carbon dioxide that had been locked in rocks was released into the air, and the atmosphere thickened until it crushed the surface beneath 90 times Earth's atmospheric pressure. At some point in the last 500 million years, the interior of the planet convulsed. Volcanism on a scale we have never observed anywhere else resurfaced almost the entire world, and Venus became what we see today. If this is what happened, and the missions of the next decade will tell us whether it is, then Venus is not a failed twin of Earth. Venus is a case study in how a world can change, in how a place with oceans and stable temperatures and everything we currently understand as necessary for life can become the most hostile environment in the solar system. This is the same photograph we started with, taken by a machine that survived for 127 minutes. For 40 years, this was almost everything we had. A handful of Soviet images, a radar map from an orbiter that stopped transmitting in 1994, and questions that no one was seriously trying to answer. That is about to change. By the end of the 2030s, we will have flown a probe through the atmosphere of Venus. We will have mapped its surface at resolutions high enough to detect active eruptions. We will have studied its interior, its clouds, and its chemistry with instruments that did not exist when the Venera program ended. We will know with reasonable confidence whether Venus was ever habitable. We will know whether it still is in any sense, even in the strange chemical sense that phosphine suggested. And we will know, more clearly than we do now, what turned a world like Earth into a world like this. We're going back. And whatever happened there might tell us more about Earth than any other place in the solar system.